So, up to now, we have discussed the selection against uh, recessive complete dominance, selection against recessive incomplete dominance, and selection against homozygotes. Now, we will discuss the selection against heterozygotes. So, suppose we have three genotypes as usual, having say A1, 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 A2, 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 and with their respective frequencies say P0 square to P0 Q0 and Q0 square, and then fitness value or selection values are 1, 1 minus S, because we are making selection against heterozygote, so it is 1 minus S and 1. Then after selection the gametic contribution is, just multiply these two, we will get P0 square. When we multiply 2 P0 Q0 with 1 minus S, we will get 2 1 minus S P0 Q0, and for A2 it is Q0 square. Their total contribution can be find out by just adding this plus this and this. So it is P0 square plus twice 1 minus S P0 Q0 for heterozygotes and Q0 square for homozygote recessive. So on simplification, you will get P0 square twice P0 Q0 plus Q0 square minus 2S P0 Q0. So minus 2S P0 Q0. Now this part is equal to 1. So it becomes 1 minus 2S P0 Q0. So the frequency after selection and one generation of random mating can be obtained, say can be given by say q1, which can be obtained by the proportion of q, this square plus half of this square divided by this total gametic contribution. That is, q1 can be obtained by q0 square plus half of this, so it is s minus 1. It is wrong, it is 1 minus s P0 Q0 upon 1 minus twice P0 Q0. So if you further simplify it, so it is Q0 square, it is 1 minus S, P0 can be replaced as 1 minus Q0 and Q0 divided by 1 minus 2S P0 Q0. If I make further simplified, or you can make it further simplified, then you will get Q0 square, then Q0 minus Q0 square minus Qs plus Q0 SQ0 square. So this cancelled out, and what we left with is Q0 minus Q0S. If I take common from these two, Q0S can be taken common with minus sign, so it becomes 1 minus Q0. Now this 1 minus Q0 can be replaced with P0. So Q0 minus S times P0 Q0 over 1 minus twice S P0 Q0. So if I take Q common from this, so it becomes Q0 1 minus S P0 divided by 1 minus twice S P0 Q0. And finally, we will get Q1 as Q0 1 minus SP0 divided by 1 minus 2 SP0 Q0. Now we will find out the change in gene frequency. So the change of gene frequency delta Q, which is resulting from one generation of selection, is given by say delta Q is equal to Q1 minus Q0. So, and if I substitute the value of Q1 and Q0 in this relation, so I will get Q0 1 minus SP0 divided by 1 minus twice SP0 Q0 This, the value of Q1 is comes from the previous slide, and this is minus Q0. So on simplification, we will get Q0 minus SP0 Q0 minus Q0 and 2SP0 Q0 square when I multiply Q0 with this term and subtract. So you will get this. Now this Q0 can be cancelled with this Q0, and we will left with minus SP0 Q0 if I take common from this term and this term. So minus SP0 Q0 I have taken out. So it becomes 1 minus twice of Q0 divided by 1 minus 2SP0 Q0. So this can be further simplified in terms of Q0 by substituting P0 as 1 minus Q0 here and 1 minus Q0 here. So you will get this expression. And on further simplification, we will get minus SQ0 first term minus minus plus SQ0 square plus 2SQ0 square minus 2SQ0 cube. And you can write like that, because this is plus 2SQ0 square plus SQ0 square, it becomes 3SQ0 square and rest of the terms as such. And finally, this if I take minus SQ0 common from these three terms, I will get 1 minus 3Q0 plus 2Q0 square divided by 1 minus 2SP0Q0. So now this 3s can be further bifurcated as say minus Q0 minus 2Q0. So I just write this thing minus SQ0 as such, 1 as such, and this 3Q0 can be written as minus Q0 minus 2Q0 plus 2Q0 square. Now what I take minus 2Q, I can take common from these last two terms. So it is minus SQ0, 1 minus Q0, minus 2Q0 if I take common, this is 1 minus Q0. So finally, if I take 1 minus 2Q0 common from these two terms, so I will get minus SQ0 and minus SQ0, 1 minus 2Q0 into 1 minus Q0. So the delta Q can be written as finally minus SQ0, 1 minus Q0, 1 minus 2Q0 divided by 1 minus 2SP0Q0, and which is nearly equal to twice SP0Q0 into 1 minus Q0 minus 1 by 2. If we take say Q0 as half, if we take Q0 as half, it means the gene frequencies are equal, then your delta Q will be 0. When I will take Q0 half, then it becomes, say, delta Q will become 0. It means equilibrium position comes. So we have find out the terms say Q1 as P0 Q0 1 minus S plus Q0 square, and on simplification we will get this expression. Now what is the purpose of doing this? Actually I want to find out the recurrent relationship. So I just arranging the terms in such a way that the recurrent relationship can be generated. So P0 Q0 1 minus S plus Q0 is my Q1. So this P0 can be replaced with 1 minus Q0. Q0 as such, this is 1 minus S plus Q0. Divide it by 1 minus 2S P0 Q0. So on simplification, I will get the Q0 minus Q0 square. When this Q is multiplied with these two terms, I will get Q0 minus Q0 square into 1 minus S as such plus Q0. And further simplification, if I multiply these two terms, then what I get? This is Q0. When minus Q0 is multiplied with 1, this is minus Q0 square. When Q0 is multiplied with minus of S, it is minus SQ0. When Q0, this is multiplied with say with this term. So you will get minus minus plus SQ0 square plus Q0 square. Now from this can be cancelled. And we get Q0 minus SQ0 plus SQ0 square divided by 1 minus 2SP0 Q0. And if I take Q0 common from here, so I will get 1 minus S plus SQ0 square like this. And if I take the reciprocal, because this is Q1, and if I want to find out 1 over Q1, so this will becomes 1 minus 2S P0 Q0 upon 1 minus S Q0 plus S Q0 square. So you can find this. Now put S is equal to 1. What happens? When we put S is equal to 1, so this vanishes and we will get in the denominator say Q0 square. So it becomes 1 upon Q, 1 minus 2 P0 Q0 over Q0 square. And on further simplification, it is 1 by Q0 square minus 2 P0 upon Q0. Now this P0 can be replaced as 1 minus Q0. So I just replace this P0 as 1 minus Q0. And if I further simplify it, I will get 1 by Q0 square minus 2 by 1 by 2. Let me check it. So it is I just simplify it because I put this thing is direct. So 1 by Q0 square minus twice 1 minus Q0 divided by Q0. So if I take LCM, so it is Q0 square. So it is 1 minus 2Q0 plus 2Q0 square. So this can be written as 1 upon Q0 square minus 2 by Q0, 2 by Q0 because Q cancelled with this plus 2. So this is 2 by Q0 minus 2 by Q0. And on further simplifying, you will get 1 minus Q0 square minus 2 by Q, and this is 1 plus 1. So if I transpose this one to other side, so it is 1 by Q1 minus 1 is equal to 1 by Q0. Now we have left this thing with us. Now what is this? This is a square. You can say 1 upon Q square is a square minus 2 AB, and this is plus 1 means B square. So this is 1 by Q minus 1 whole square. So this can be written as 1 by Q0 minus 1 whole square. And 1 by Q1 minus 1 can be written as 1 minus Q0 minus 1 whole square. And if I want to find out, say, in next generation, this is what is the value of 1 by 2 1 by q2 minus 1, this can be written as 1 by q1 if you use this analogy whole square, and if I substitute the value of 1 by q here, so 1 by q is nothing but it is 1 by q0 minus 1. 1 by q minus 1 can be written as 1 by q0 minus 1 whole square. So it becomes raised to power 4. So if you find out, if you go on like this and ultimately you find out 1 upon qn minus 1 raised to power, what is the value of this in terms of q0? So for 1 it is square, for 2 it is raised to power 4. So for n it is 1 upon q0 minus 1 raised to power 2n. So 1 upon qn minus 1 will be equal to 1 upon q0 minus 1 raised to power 2n. If we take log on both sides, taking logs on both sides, what we will get? Log of 1 upon q minus 1 is equal to the power can be used as multiplier. So 2n log 1 upon q0 minus 1. So this relation can further be simplified. Log 1 upon qn minus 1 is equal to twice the log q0 minus 1. Now, there are certain cases. We will study various cases. First case, when your q is less than half, means the frequency of recessive allele is less than the frequency of dominant allele. So if q is 1 less than half, so it means 1 by q0 is greater than 2. So in first case, when q is less than half, which implies that 1 by q0 will be greater than 2. Then what is the value of this term, this equation? So log of 1 by qn minus 1 is equal to twice log of 1 minus q0 minus 1. What happens? When n tends to infinity means the number of generation is very, very large. Then log of this will also tends to infinity, which implies that 1 upon qn minus 1 will also tends to infinity. So if you subtract or add 1 to infinity, it doesn't change. 1 by qn also tends to infinity, which implies that your qn will be 0. When qn will be 0, it means the gene frequency in nth generation for recessive allele is 0. It means A will be removed from the population. So when your q is less than half, so over a large number of generation, the allele will be lost. Case 2, when q is exactly half. So in this case, what happen? You will study this. Now, log of 1 upon q minus 1 will be 0. When q is equal to q0 is equal to 0, so it becomes minus. So it will become 0. This part becomes 0. And 1 upon qn minus 1 will be equal to 1. If I just implies, so 1 upon q will be 0. It means log of, if you subtract the log, then it will be equal to 1. Because e raised to power 0 is equal to 1. So if you take e raised to power 0 from this relation, you can find out the value of this term just by taking e raised to power this side. So it is 1. So which gives us 1 upon qn, because 1 upon qn minus 1 will be equal to 1. This implies that 1 upon Qn will be equal to 2. It means Qn will be equal to half. When Qn will be equal to half, it means gene is still present and it reaches the equilibrium. When P is equal to Q is equal to half, means it stabilized at say half. So equilibrium condition will be reached. So when Q0 is equal to 0, so for large n, or you can say the population will be in equilibrium. Case 3, when Q0 is more than half, Q0 is greater than half, it implies that it implies that 1 is greater than 1 upon Q0 minus 1 when your n is very, very large. So you can say that 2n log E 1 upon Q0 minus 1 will be tends to minus infinity. Implies left hand side will be equal to minus infinity. But we know that log of base E 0 is also infinity. It means 1 upon Qn minus 1 will be 0. This implies that 1 upon Qn will be 1, which further implies that Qn will be 1. When Qn will be 1, what does it mean? It means all the genes are of, say, homozygous recessive. It means the gene P, the frequency of P is 0. It means the capital A will be removed from the population. When P is 0, it means the frequency of P is 0, means allele A is removed from the population. So now we will find out the number of generations required to affect the amount of change in Q. So exactly on similar manners, we know that the change in gene frequency will be equal to delta Q will be equal to 2SPQ minus half plus Q, which implies that dQ by dt is 2SPQ minus half plus Q. And if you separate Q on one side and dt on other side, you will get this expression. And now if we integrate both sides over n generation, what will happen? So we will just integrate in the range Q0 to Qn dq 1 upon Q into Q minus half is equal to 2s dt. So the right hand side will be equal to 2sn, as we have seen in previous sections. So using partial fractions, we will integrate this part using partial fraction. So I will take this thing as say a by 1 minus q, b by q plus c by q minus 2. And this can be written like that. If I take the LCM and multiply, so I will get 1 is equal to AQ, Q minus 2 plus B into 1 minus Q, Q minus 2 plus C into Q, 1 minus Q. Now I will substitute, say Q is equal to 0. When I substitute Q is equal to 0, this term vanishes and this term vanishes. I left with this. So what you will get? B 1 minus 0 minus half. So you will get 1 is equal to minus half b, which implies b is equal to minus 2. Similarly, when you put q is equal to 1, it implies that if you put q is equal to 1, so a into 1 minus 1 minus half, so it is half, and rest of these two term will be 0. So it is a by 2, which implies a is equal to 2. And when we put q is equal to half, you will get c is equal to 4. Now, substituting these values of a, b, c in this partial fraction, the ultimately we will get 1 divided by 1 minus q into q minus 2 can be written as 2 by 1 minus q minus 2 by q plus 4 by q minus half. Now integrate it. So the integration of this can be written as integration of 0 to q 2 by q minus 1 minus q minus 2 by q plus this. So all these comes under the log. So it is twice log of 1 minus q minus 2 log q plus 4 log and so on and so forth. So in next slide the complete integration is there. So it is like that. So if I substitute the limit from this part, I will get 2 log 1 minus q and minus of this because we have this coefficient minus twice log q from this 4 log q minus half in the range q0 to qn. So if I further simplify it, I will get this. And on further simplification, ultimately you will get log of q minus half whole square divided by q into 1 minus q in the range q0 to qn. And now apply these limits, we will get this expression. And finally, ns can be written as qn minus half whole square divided by qn 1 minus qn multiplied by q0 1 minus q0 divided by q0 minus half whole square. So from this we can find out n. So n can be calculated like this.